Today we're going to take a look at section 4.1, which is about divisibility. Bear with me for the first couple of slides. They seem a little bit disconnected. I'll try to make the connections to the second part of it. The second part of it's the part that I was telling you about that you'll find direct kind of application usability for what you're doing at the lower grade levels. So, first of all, a definition of what divides means. If we have two numbers, A and D, and they're whole numbers, when we say D divides A, what we mean, well, sometimes what the word we say is we mean divides evenly. Okay, it means that there's a number Q such that A is equal to DQ. That's not Dairy Queen. If D divides Q, we would say D is a factor or a divisor of the number A. And we would also say, likewise, that A is a multiple of D. Now there's a bit of notation on this screen that's a little awkward. And it's just awkward because of what you're used to with fractions. This line means divides. So this is saying D divides A. Okay? So you can think about it as like if you divide it like this, that might be a nice way of thinking about it, left to right, about a division, old style division from the younger grades. But it actually looks like a fraction upside down as well, right? Oh, I didn't mean B, D. Okay, so the D is the denominator, and it comes first in this new notation that you're seeing right here. It's first. D divides A. Now let me think with you with some numbers so you can see how this makes sense. We would say that 4 divides 20. And you agree with that, right? 4 divides 20. This is how we would write it. The smaller number comes first, 4, and then the 20. And what it means for 4 to divide 20 is that there's some number that I can multiply 4 by and actually get 20. That's what it means, that there is a number here, and it's a whole number that will fill in that gap. And of course, you all know what that number is. 5, right? So there's a 5 here. Okay, so if you're talking about something dividing, it means there's no remainders, there's no fractional part left over, none of that's going on. So we've got some different facts about division that are going to come about in these first few slides. This is the first one. For any whole number, A and D, if D divides A and N is any other whole number, then D divides NA. And we'll just carry on with the same example that I did previously. We said 4 divides 20, and nobody fussed at me, so we must be okay with that, right? Well, what this means is that 4 divides 20 anytime 20 is multiplied by something else. So somebody give me a number that 20 could be multiplied by. It's got to be a whole number. 5. Okay, so 20 times 5 would be 100, right? So does 4 divide 100? Yes, it does, right? No problem. It's 25 if I were to divide it. Another way you could think about this, or think about maybe why this is true, because I just gave you one example. One example is not enough for you to be like, all on board, yeah, absolutely works every time. That's a bad place to be if you think that way, okay? So let me talk a little bit just for a sec about why this should make sense in general from a fraction standpoint. Now, I know we haven't done fractions in this class, but of course you did fractions back in junior high and high school. This is what we said is the equivalent to writing 4 divides 20, right? I can write it like this, 20 divided by 4. Now think about what happens when I write, oh, I didn't mean to put that, I meant to put an arrow. Think about what happens when I put any number beside the 20. Well, what you'll remember from fractions is that I could actually just look at this pair to reduce it, and this pair doesn't affect anything, right? It's reducing common values. If you've taken proportional statistical reasoning with us, we talk about it in there. But we can reduce, when it's multiplication, this doesn't work for addition, can't do that, but with multiplication you can reduce it that way. So anytime we have a number that divides something, it's going to divide all multiples of that. All right, I have 5 facts we're going to write down together, and we'll talk about them as we go. The first fact is we're going to say if D divides A, much like the last example, but we're also going to have D divides B. then D divides A plus B. And again, I'm not proving these per se, but I am going to argue with some numerical examples about why this makes sense. Are you guys good with that? Okay, so if I were to take this example, for whatever reason I really like 4s and 20s today, so we'll keep going with that. So if 4 divides 20, tell me another number that divides 20. I'm sorry, another number that 4 divides. I said that backwards. 16, fantastic. 4 divides 16. Whoops, 16. Okay, so that's what this is saying. I have 4, and it divides 2 numbers. They could be the same number, but they don't have to be. Okay? And the statement is then that 4 is going to divide 20 plus 16. What's 20 plus 16? 36. Does 4 divide 36? Yeah. So why is that working? Well, again, if you think in terms of a fractional standpoint, we're saying 20 is divisible by 4. We're saying 16 is divisible by 4. And we're saying that when we add 20 and 16, they each divide by 4. And I mentioned just a moment ago that this fact over here only worked for multiplication, right? When you're looking at addition, you actually have to see if it's both pieces of the addition, both pieces of the sum are divisible by the denominator. And if they are, then you could reduce them both, right? You'll remember doing things like 4a plus 4 divided by 2 in algebra. And what you said is, oh look, the 2 goes into the 4 2 times, and it goes into this 4 2 times, so I'm able to reduce it. That's all this fact is telling us, okay? All right, let me do the next one. The premise starts out very similar, D divides A, but now we have the fact that D does not divide B. So when that's the case, then D is not going to divide A plus B. Now I used a new symbol. Should be okay. You just put a slash through something, it means not, right? We've done that with elements, we've done that with equal signs, that kind of stuff. So now we're going to do it with this divides symbol. And again, we can think about that same 4 and 20 if we'd like. 4 divides 20, and give me a number that 4 doesn't divide. 11. Sure, 11. 4 does not divide 11. And so if I take 20 plus 11, that would be 31. Will 4 divide 31? No, it won't. And again, if you think about it from a fractional standpoint, like we're good with the 20 divides as divisible by 4, we can write 11 over 4 as a fraction, that's fine. But if we take the 20 and we take the 11, the reason this isn't going to divide is because while this fraction divides, that fraction doesn't. Right? I can't reduce both pieces, the 20 and the 11, by 4. All right. The next 3, so these two go together. You can see, right? The example and a non-example, what has to happen. The next 3 also go together. So we're going to say D divides A again, and D divides B. So we're starting out much like the very first bullet point. We've got one additional fact on this, that A is greater than or equal to B. It only matters because we're trying to stick with whole numbers because we haven't actually learned about integers in theory yet, because that's chapter 5. Okay, so this fact right here is sort of really not that important. It's just only important to keep us in the whole number system. Okay, so what we're going to do is we're going to do the same thing that we just did with addition, but we're going to do it with subtraction. So then D will divide A minus B. And right there you can see why we wanted A to be bigger, because then A minus B would be a positive number. If I use my very first examples that I had, 4 divides 20 and 4 divides 16 again, then we could say that let me draw a line here. We could say, of course, that 4 divides 20 minus 16, right? What's 20 minus 16? 4. Does 4 divide 4? Yeah, it's 1. Absolutely, so no problem with that. And again, from a fractional standpoint, again, it works the same way because each of those fractions are divisible by each of those numerators pieces, right? The 20 and the 16 are divisible by the 4. So since each of these pieces divides, we're good to go. So if we did it with the division, or with both pieces being divisible by, now we're going to do it with the second piece being not divisible by, again mirroring the second piece that I had before. D divides A, D does not divide B. And again, we're going to stick with A as being bigger than B so that we can stick with whole numbers. So what do you think is going to happen then when I subtract? Will it divide or will it not divide? I bet 50% of you at least know the answer and you're just not wanting to talk to me today. So I just said it's like this one, right? It's not. Yeah, Cassidy's right. It's not going to work. The fact that I have one piece that divides at the beginning and one piece that doesn't causes a problem. So if we take, whoops, this will be D does not divide A minus B. So we can use the 4 or the 20 and the 11 that we had on example number 2. So if I did 4, and the question will be, will 4 divide 20 minus 11? Well, what's 20 minus 11? 9. Does 4 divide 9? Not evenly, so no. Yeah, this doesn't work, so 4 does not divide 20 minus 11. And again, if you think about it from the standpoint of fractions, one piece of the numerator divides, 20 and 4. The 11 does not divide by 4, right? Yeah. All right, our last one of these, and it does go with the 2 before, is all it does is it changes the fact that the divisibility is at the beginning. So D does not divide A this time, and D does divide B. A is still greater than or equal to B. So if one of them divides, and one of them doesn't, what do you think is going to happen when I subtract? It's not going to work. Right. So D will not divide A minus B. Now you might be looking at that and saying, well, isn't that basically just the same as the problem before? And it is, but you'd actually have to be able to do the division in reverse, or the subtraction or the numerator in reverse. So let me give us a couple other numbers. So let's say we've got 4, and we need the number does not divide first. So let's do 4 does not divide the 11 to start with, okay? And then I need a number that 4 does divide, but it has to be smaller than 11. 8, okay, so 4 divides 8. So if I were to do this now, the question would be, does 4 divide 11 minus 8? And what would 11 minus 8 be? 3. Does 4 divide 3? No, this doesn't work. And again, it doesn't work because the fraction, or at least one other way to think about it, is because the fraction itself does not have divisible parts on the top. The 8 works, the 11 doesn't. Okay, so we're going to come back to some of these pieces in here as we continue, but we're going to shift gears a little bit to talk about very concrete divisibility rules. That's what we're looking at next. So on your paper, you have the divisibility rules for 2, 5, 10. This is the front page. And these are grouped together on purpose, and the reason they are is because their divisibility rules are quite similar, okay? So, as you can see, the first thing says a whole number is divisible by 2 if and only if what? How do you look at a number and know it's divisible by 2? Okay, it's even, but you could say that even is just another way of saying divisible by 2. What do you really look for? Very specifically. If a child did not know what even meant, how would you describe it? Okay, so specifically like 0, 2, 4, 6, or 8, right? But where does that number need to be, Brianna? At the end, right? So that 0, 2, 4, 6, or 8, it doesn't matter what happens toward the beginning of the number, like if we have a 2 or 3 digit number, right? It's only the end of the number that matters. And that's our divisibility test for the 2's. So when this says even, Specifically, it means that it ends in a 0, 2, 4, 6, or 8. And if you take a look at divisibility by 5, you see that same thing happen, right? How do you know something's divisible by 5? Yeah, it ends in 5 or 0. Do you see this? The units digit is 5 or 0. And then the last one, how do you know if it's divisible by 10? It ends in 0. The units digit is 0. So that's why these three are grouped together, is because all you have to do to decide is look at the ending digit. Divisible by, or if it's divisible by 2, 5, or 10, you look at the last digit to make that decision. Does that make sense to everyone? Okay. All right, 4 and 8 go together. All right, so in 4 and 8, you kind of say that they go with 2. We talked about that the last digit needed to be even. We talked about what that last digit's number could say. Another way to say that the last that a value is divisible by 2 is that the last digit of the number is divisible by 2. And that makes sense, right? 0, 2, 4, 6, and 8 are all divisible by 2. So that's the actual, another way of saying the same rule for divisibility by 2. But you only look at the last digit, right? All right, so when you do divisibility by 4, what you do is you look at the last 2 digits. And you look at that value. So if the last 2 digits are 24, is 24 divisible by 4? Yes. Then no matter what the number is, the whole thing's going to be divisible by 4. And if you look at the last digit for divisibility by 2 and the last 2 digits for divisibility by 4, what do you think you might do for divisibility by 8? The last 3 digits. And that's why these are grouped together. And when we look at the last 2 digits, I mean as though it's a standalone digit. It's a value itself. You know, it's the actual number. So like if the numbers are 2 and 4, the number's 24 we look at. If the last 3 digits are 4, 6, and 7, the number's 467 that we look at. Okay, does everybody have both those down? Nope, not yet. Okay. Okay, 3 and 9 go together. They're the same type of rule. Does anybody know the divisibility rule for 3? I actually learned it in high school, so do you know it? Close. You add together. Does anybody know? Can anybody help her?
You add all the numbers, and if that is divisible.
Right. It's all the numbers. Yeah. So you take whatever numbers you have, their individual values as units. You add all the digits together, and if that sum is divisible by 3, then the number that you started with was divisible by 3. It's a cool one. It was one of the, I seriously learned it as a senior in high school, and I thought like I had struck gold or something, because how did I never know that? That's what I felt like, because I thought that's such a cool property. Super easy. But the cool thing is it doesn't work just for 3s, it also works for 9s. So what do you think I might have to adjust to make this statement about 9s? Not above 9, but you're getting close.
9 itself?
Not 9 itself. Is divisible by 9. Who said that? Yes, that's right. So if the sum of the digits is divisible by 9, then the original number is divisible by 9. Just like with the 3, the sum of the digits is divisible by 3, then the number is divisible by 3. Okay, so the next one, super awkward. It's easy to test, but I have yet to find a way to write it down that's easy to write it down. Okay? It's kind of like one of those people, you know, when they ask you, what does this word mean? And you're like, well, I mean, I know what it means, but I don't exactly know how to describe it to you, right? It's like that. My teenage children speak another language. They speak a language called Amharic, and they said something the other day, and my husband said, well, what does it mean? And they were like, there is no English translation. And we were like, well, that's not true. That can't make any sense. It has to mean something, right? So this is the divisibility test for 11. I'm going to let you write it down, and then I'll show you how it works, because it doesn't really sound very nice to write down. A whole number is divisible by 11 if and only if the sum of the digits in the places of even powers of 10 minus the sum of the digits in the place of odd powers of 10 is divisible by 11. So do you see what I mean by how awful that sounds? Sam's like, yeah, absolutely. It sounds terrible. But I know no other way to write it. So let me show you how you actually apply what I've written down. I'm just going to make up a number that's got lots of digits, okay? You don't have to have lots of digits for this to work. It just is easier to show you how it works with lots of digits. So 2, 4, 1, 7, 6, 8, 1, 9, 0. I don't know, whatever it is, okay? So what you do is you take every other number. So I'll take 2, 1, 6, 1, and 0. So these are my orange numbers now. What is the sum of these orange numbers? Yeah, it's 10. So the numbers in orange sum is 10. Now I'm going to take the numbers that I'm highlighting in red, and we'll add them together. 4, 7, 8, and 9. So what is 4 plus 7 plus 8 plus 9? What do we get? 26, 28, which one is it? 28, 11, yeah, 28. Okay, so we've got 28. So what we do is we do every other digit and we add them up. Okay, so that's what this is talking about when it says the sum of the digits in the places of odd powers of 10. So that's every other is an odd power, right? We have 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3. Place values, right? Okay. And then we subtract. What's 28 minus 10? 18. If that number that we get at the end is divisible by 11, then the original value is also divisible by 11. So, does 18 divide by 11? No, it doesn't. So, the original number, the one I made up, is also not going to be divisible by 11. Okay, so it's not hard to do the process, but it's really awkward to write it down. All right, divisibility test for 6. You probably already wrote it down because you saw it on the screen. It says the whole number is divisible by 6 if and only if it is divisible by both 2 and 3. So any ideas about why that would make sense, or what is it about that that makes it reasonable?
Those are the factors of 6.
Yeah, that makes sense, right? Those are the factors of 6. So we're going to pause for a second and see if there's a way to extend this idea to other numbers that are multiplications or products of two numbers. So I'm going to just flip to the end of my lesson to give us a blank slide, because sometimes I have time to do this with a class and sometimes I don't. So I don't have you guys specifically grouped up right now within any kind of group, so let's just kind of partner up with who's beside you. So Sam and Haley, you guys can be together. And then I've got an odd number right back here, don't I? So is it Brianna or Brianna? Brianna. Even as I said it, I was like, that didn't sound right. Brianna, if you'll move forward one so that you've got a partner, and then we will do Kayla and Ariel, and then if you'll move forward one and be Zion's partner, I think that pairs everybody up because we've got an even number today. Is that good with everybody, just across the aisle? Okay. What I'm going to do is I'm going to write on the screen examples where you can do like the 6. I can multiply the two numbers together and know that if it's divisible by 2 and 6 is divisible by 10. And then I'm also going to give you some examples of numbers where when I multiply them together, it doesn't, and they're each divisible by 2 numbers, it doesn't exactly work. So let me give you a couple of examples first. So we already said that if it's divisible by 2 and 3, then it's divisible by 6. That works. That's divisibility 6. If it's divisible by 3 and 5, it is definitely divisible by 15. Okay? If it's divisible by 3 and 4, it's divisible by 12. Let me have one more. How about if a number is divisible by 4 and 9, it will be divisible by 36. Those are all examples. They follow the same thing that we just did with 6s, okay? Now I'm going to give you some non-examples. Okay, so if a number is divisible by 2 and 4, it does not have to be divisible by 8. It might be, but it doesn't have to be. If a number is divisible by 4 and 6, it does not have to be divisible, by 24. Multiply my 4 by 6. If a number is divisible by, I don't want to use 4 again, let me use 3. 3 and 6. It does not necessarily have to be divisible by 18. How about 9 and 12? Being divisible by 9 and 12, what is 9 times 12? 108. Does not necessarily divide by 108. So here's your goal with you and your partner. Try to be a little bit quiet so that everybody has a chance to think through it and try and figure out what the clue is. This is like a riddle, right? It's a game. What is it about these numbers on the left that makes sure it's divisible by the one that follows that fails to happen to the numbers on the right? How are my left-hand column of digits different than my right-hand column of digits? Don't say it out loud. Talk to your partner. See if you can come up with what's different in these two sets of numbers. I'm going to add one to it. Because you guys said, I noticed 6 is on the left column, it's not on the other one. So how about 6 and 5? Guaranteed divisible by 30. Did anybody figure out a pattern? A couple of groups. Okay, so instead of telling what you think the pattern is, Cassidy, can you create an example for me that will work based on your pattern?
I think they could do that. Let's just go for it.
Can anyone create an example for me that you think, based on your pattern, would be one that works? Do you have one, Taryn?
7 and 6.
Yes, it will. Yep, that one works. I almost wrote that one down a minute ago when I did the 6. Yep. 5 and 4 would work. Yes, it would. Can anybody give me an example of one you think would not work? Nope, 7 and 2 will work. It's a good guess.
8 and 4.
8 and 4 would not work. 6 and 2 would not work. You think of another one that would not work. 6 and 6 would not work, but that's not a, because it's the same number. 6 and 8 would not work. Did I have 6 and 8 on my list yet? No, I didn't. 6 and 8 would not work. What is that? 48. Okay, so I think we've got at least 2 or 3 groups that maybe figured out what they were looking for, because you are giving me some examples that do and don't work. So would somebody like to share with us what you think it is that makes the first list work and the second list fail? What is it? What's causing it? Taryn?
I don't know if this is right, but
It's okay.
he said the left-hand column, if put into a fraction, cannot be reduced, and the right-hand column can.
That's a really good way of saying it, and I've never had anyone say it that way before. That's excellent. If you take a look at any of these pairs of numbers and you put it into a fraction, this is how Taryn said it, they could be reduced. Does everybody see that?
Yeah.
And the first list could not. Lovely way of describing it. The kicker is that this whole lesson's about divisibility, right? The first set of numbers on the left don't have any divisible number for both numbers. There's no number that divides both of them. And that's why the fraction doesn't work, right? It doesn't reduce. On the right-hand side, every pair of numbers on the non-examples have a number that they both divide by. Do you see it? Yeah. So if I were to ask you now to give other examples in this list, could you create some? Yeah, because you're looking for factors in common. You're looking for ways that they could be reduced if you wrote them in a fractional form. Okay? So this divisibility rule for 6 is very unique, and it doesn't work for every pair of numbers. It only works for pairs of numbers where the two numbers don't have any factor or don't have any factor or divisor in common, except for 1. Everything has 1 in common. That's sort of a given, okay? So we're not talking about that one, but no other number but 1. All right, we're going to come back to this a little bit later, but let's jump back in where we were before with example 1. It says without using a calculator, because we all know that we can use calculators. I mean, like, that's not going to be really useful here. We're going to decide if a specific number, and our number is 24,015, is divisible by 2, 3, 5, 6, 8, 9, 10, and 11. Now, you're going to be doing problems like this in your homework, where you're either going to be given a number and told to decide if it's divisible by a list of numbers, or where they'll give you a part of a number and they'll ask you to fill in the blank. Like they'll say, like they might have given you the number 2 blank 015, and they want you to fill in this number so that it is divisible by whatever, okay? So some of the numbers are given to you in that fashion. So what we're going to do as we're looking at these is that we're going to write down on our notes anyway why it works or doesn't work, how it is we're making that decision. If your book says on an example problem that you have to justify it, then that's what you would do. If it doesn't say you have to justify it, it's okay if you don't. That's fine with me. I'm not going to take off if you don't, I mean, for following the directions, obviously. But I think it's a good idea, if at all you use your homework to reference back, which I hope you do, to write something down so that you can remember later on, because like this is the first lesson for the next like 3 weeks before we have another test, and you're probably not going to remember all of it in 3 weeks. So if you have more written down on your homework just for your own reference, that's probably a good idea. All right, so as we do the notes, we're going to do that. 2. Will 2 divide 24,015? No. Why not? Yeah, because 5, it's specifically the number 5 is odd, right? The number 5 at the end. 3. Will 3 divide? How do you know? You add them together. So you've said yes. The reason is because 2 plus 4 plus 0 plus 1 plus 5 is what? 12. And 3 divides 12. So since 3 divides the sum, 3 will divide the original value. How about the number 4? No, why not?
15 will not divide by 2.
Right, the last 2 digits as a 2-digit number, 15. They don't divide by 4, so 4 does not divide 15. What's our next one? 5. How about 5? Yes, why? Because it ends in 5. Nice. How about 6? No, why not?
It is not divisible by 2.
Right. It's not divisible by 2.
But like if it were like just for a different number and it said yes on both 2 and 3, it would be divisible by 6.
You got it. If it were divisible by the 2 and the 3, it would be divisible then by the 6. Yes. 6, 8. No, why not? Yeah, the last 3 digits. So the last 3 digits are 0, 1, 5, right? And does 8 divide 0, 1, 5? No. So the divisibility rule for 8 is fine and it works. It's not always the most useful because I don't know about you, but I don't know many divisibility facts of 8 that go high enough into a 3-digit number. Agreed? But even if you were in a position where you had to do that division by hand, dividing that 3-digit number by 8 would be easier than dividing the 5-digit or the 8-digit number by 8. Are you guys with me on that? Okay. I'd like to pause also and make note of something else here. As soon as we said something wasn't divisible by 2, 4 and 8 fail automatically. And the reason is if you think about your multiplication tables of 2, 4, 6, 8, 10, 12, and so forth, when you multiply by an even number, what do you always get? An even number, right? So if it's not going to be divisible by 2 to begin with, then it's not going to be divisible by 4 because that's a multiple of 2, or 8, or 10, or any of the multiples of 2 actually. So something to be aware of as you're looking at the values. 9 is next. Is it divisible by 9? No, why not? Right. When we did the sum before, 2, 4, 0, 1, and 5, we got 12, right? And 9 does not divide that 12. How about 10? No, why not? Right, because it doesn't end in 0. Let's see, our last one's 11. Okay, so we already talked about how 11's a little weird. I'm going to leave a blank spot for answering the yes or the no, and let me write the number down, 2, 4, 0, 1, and 5. Do you remember what we did? Added every other number, so that'd be 2, 0, 5. So what are my red numbers? 7. And what are my blue numbers? Yeah, 4 and 1 would be 5. And if I were to subtract these, what would I get? 2. Does 2 divide by 11? No, it's too small, right? Yeah, so this is a no. And at the end, it's because 11 does not divide the number 2. Okay. So you can run through the divisibility of a particular set pretty quickly. Okay, so I mentioned we were going to come back to this idea of the property for divisibility by 6, and this is the example where I was referring to. Example number 2. It says to classify each of the following as true or false. The first question says if a number is divisible by 6, then it's divisible by 2 and 3. Is that true? It is true. That's exactly the divisibility rule that we have. And part B that says if a number is divisible by 2 and 3, it's divisible by 6. Also true. Now if you go back and you look at your divisibility rule for 6, the reason that this is the same is because it says if and only if down here. 6 means divisible by 2 and 3. 2 and 3 means divisible by 6. So that's the two parts to part A and part B to problem number 2. Okay, it works both directions. C is a little different. Okay, C says if a number is divisible by 8, is it divisible by 2 and 4? Whereas D says if it's divisible by 2 and 4, then it's divisible by 8. Now, it's part D that we did the example for on our work together in groups. Divisibility by 2 and 4 does not necessarily mean it's divisible by 8. So this is false on part D, okay? That's just like what we did before. And a good way to think about or to decide if something's false is to give a counterexample. Can you give me an example of a number that's divisible by 2 and divisible by 4, but not divisible by 8? 12 is a good example. In fact, it's one of the smallest ones. So let me write down. We call this a counterexample, right? But this example is showing that it doesn't work. 12. 2 divides 12, right? Yes, it does. 4 divides 12, right? Yes, it does. 8 does not divide 12. Yeah, it fails. We haven't actually talked about C, though. Just being able to go one direction for part D and saying it fails doesn't necessarily mean the other direction will. Okay, so let's think about number C or letter C on this one. If a number is divisible by 8, so it might be good if you think for the moment of your multiplication tables for 8s. What would I list as my multiplication tables for 8s? 8 and then what? 16, 24. Give me just a couple more. Okay, and we recognize that it goes on. The question is, are all these numbers, as they go on forever, going to be divisible, let's just do it one at a time, by 2? Yes, they are all even, right? I can't consecutively add 8 to every number, which is what multiplication is, and end up with an odd number. Agreed? Okay. Check these numbers. Are they all divisible by 4? Yes, they are. Okay? So this direction of divisibility actually works, and it works always for these others too. These examples that we did at the end, the ones that I called non-examples, if you started with any of these, the 8, the 24, the 18, the 108, and asked yourself the same question, are they divisible by 2 and 4? Are they divisible by 4 and 6? The answer would be yes. Okay? So anytime you take a number and you break it down into its factors, whether the factors are, have anything in common or not, this will work. So this is actually a true statement. And we will come back to that fact that's sort of presenting itself right here when we finish this lesson in another example too, and how that works, all right? So we're going to pause right there. We got a couple minutes left, but we're good for today, and we'll pick up with example 3 next time.